Welcome. Today I am going to discuss about distributed shared memory. First I will go for abstraction and advantages, disadvantage of distributed shared memory. So distributed shared memory is nothing but is an abstraction provided to the programmer of a distributed system. So in distributed shared memory, the processor only communicates with through the read and write operations in shared virtual space. It does not support any send and receive primitives by applications. So under covers, send and receive primitives only used by the distributed shared memory managers. So in distributed shared memory, locking is too restrictive. So it is in this need concurrent access. So in distributed shared memory, we make the replication of the data. So with replica management, the consistency problem may be arises. So it is the weaker consistency model. Is the basic structure of distributed shared memory. In distributed shared memory, there is a shared virtual memory. It contains memory managers. So the responsibility of memory managers is allocate the space for each and every processes. So the processes request the memory manager to allocate the space. The memory managers send the response to each and every process that gives the request. So advantages and disadvantages of distributed shared memory. So advantages. It provides the shields programmer from send and receive primitives. That means in distributed shared memory, communication across the network is achieved by the read and write abstractions. So it simplifies the task of the programmers. So next advantages is say single address space is provided. So it simplifies the parsing by reference, parsing complex data structures. The next advantage is, so if a block of data needs to be moved, the system can exploit locality of reference. This will be reduce the communications overhead. So DSM uses the simpler software interfaces and cheaper off-the-shelf hardware. So the system maintenance cost and the total cost is cheaper than the dedicated multiprocessor system. So in distributed shared memory, the single bus carry the data. So there is no memory access bottleneck by a single memory access bus. Then we effectively provide the large virtual memory space. The another advantage of DSM is it provides portability of programs. So that is written using DSM. So this portability arises due to the common DSM programming interface, so which is independent of the operating system than other low-level system characteristics. Next, disadvantages of DSM. The first one is, so programmers need to understand the consistency model. So already I said DSM is a weaker consistency model. So the programmers must know about the consistency model to write the correct programs. Then another disadvantage is the implementation of DSM uses the asynchronous message passing, that is read and write. So hence cannot be more efficient than the message passing implementations, that is send and receive primitives. So by yielding the control to DSM manager software, programmer cannot use their own message passing solutions. So programmer must use the predefined solutions. It cannot be the effective one. So next, issues in implementing DSM software. So DSM software contains some issues. So first issue is semantics for concurrent access must be clearly specified. That means we have to determine what semantics to allow for concurrent access to share the objects. So you have to clearly specify the semantics for concurrent access that is used to that the programmers can code his program using an appropriate logic. So next issues in DSM is determining the best way to implement the semantics of concurrent access to share data. So the best one of the possibility is to use replications or partial or full or read only mode or write only mode semantics. So another issues is location for replications. So selecting locations for the replications, it is used to optimize the efficiency from the system viewpoint. Then another issue is if full replication is not used, so determine the location of the nearest data for the access. So another issue is reduce the delay, reducing the communications delay and the number of messages that are involved under the covers while implementing the semantics of concurrent access to share data. Next, there are 4 broad dimensions along which the DSM systems can be classified and implemented. The first classification is whether data is replicated or cached. The next one is whether remote access is by hardware or software. The next one is whether the caching and replications is controlled by hardware or software. The last classification is whether the DSM is controlled by memory management or distributed memory managers, by operating systems or language runtime system. Next, comparison of early distributed shared memory system. This is a type of distributed system, shared memory system is early invented. The first distributed shared memory system is single bus multiprocessor, then switched to multiprocessor and NUMA system, page based DSM, shared variable DSM, shared object DSM. So these are classified by the previous discussed factors. That is this. So whether data is replicated or caches. So these things, by using these things, we are classified various distributed shared memory system. So example of single bus multiprocessor system is Firefly and Subsequence. So switch multiprocessor is Alive and Dash. Then Butterfly and CM Hash is the NUMA system. Then Ivy and Marriage is the page-based DSM. Then Midway Moonin is the shared memory variable DSM. Then last one is Linda and Orca is the shared object DSMs. So these single bus. The next we'll discuss about the management of DSM. So single bus multiprocessor is managed. Single bus and the switched multiprocessor is managed by the memory management unit, that is MMU. Then page NUMA system and page based system is managed by the OS, operating system. Then shared variable DSM and shared object DSM is managed by the language runtime system. Then caching method for the various DSM system. The single bus and the switched multiprocessor is a hardware controlled by the hardware. Then NUMA and page-based system is controlled by the software. Then shared variable and shared object DSM is controlled by the software control. The next factor is remote access. So in single bus and switched multiprocessor and NUMA system. So in these DSM, so data is remotely accessed by the hardware. And page-based DSM and shared variable DSM, then shared object DSM. So in these distributed shared memory system, the data is remotely accessed by the software. So those all things are classified by these 4 classifications. So data, accessing data, then remote access, then caching and replications, and DSM control factor. So next important topic of distributed shared memory is memory consistency model. So the important factor of memory consistency model is memory coherence. So memory coherence is nothing but the ability of the system to execute the memory operations correctly. So as in a processes has a n processes. So memory is contains a Si memory operation by Pi. So Pi processes contains the memory operations generated by the Si. So it is the equations for possible interleavings of the operations issued by the processes, that is S1 plus S2 plus up to Sn factorial divided by the S1 factorial, S2 factorial up to Sn factorial. So it is also defines the interleavings which are permitted. So traditionally the read returns, one of the equation is the execution is completed by read returns the value written by the most recent write. So most recent write is ambiguous with the replicas and concurrent accesses. So this DSM consistency model is conduct or employed between the DSM system and the applications programmer. So these figures shows the sequential invocations and response in a DSM system without any pipeline. So these show the processes and these show the local memory manager. So first operation, invoke the first operations. The manager returns the response of the invoking operations. So sequentially invoke the various operations, and also manager gives the response of various operations. So next important things in memory consistency model is strict consistency. So strict consistency is the sum of the property must ensure in the strict consistency. So that is the read should return the most recent value written per global time axis. So that is any read to a location is required to return the value written by the most recent write to that locations. The next property of strict consistency is all operations appear to an atomic or sequential manner. So execution of all operation is sequential. The next important property is all processes see the same order of events, that is same ordering of events which is equivalent to the global time occurrence of non-overlapping events. So this is the example for strict consistency. So all operation is a sequential manner, then all the execution is sequential manner. This is the string consistency. So that it is ensure the following property. So must ensure the following property.